In the next few videos, we're going to talk about sum or difference formulas in trigonometry. In this example, we're going to talk about the difference formula for tangent. The difference formula for tangent is tangent of alpha minus tangent of beta divided by 1 plus tangent alpha times tangent beta. Suppose you're asked to find a difference formula and use it to get the exact value of tangent 75 degrees. The first thing we want to do is to rewrite tangent of 75 degrees as the difference of two angles whose coordinates we already know based on the unit circle. For example, I know that 75 is the difference of 120 minus 45. I'll call tangent of 120 alpha, and tangent of beta is 45. So 120 is alpha, beta is 45. Then I'll take a look at my formula and I'll plug my values in. So tangent of alpha is tangent of 120 degrees minus tangent of beta, which I'll rewrite as tangent of 45 degrees. Oh, I have a talking baby here. Then the denominator will be 1 plus tangent of 120 times tangent 45 degrees. Now I'll rewrite this expression with our values. For tangent of 120 minus tangent of 45 divided by 1 plus tangent 120 times tangent 45. By now you should be fairly familiar with finding exact values of trigonometric functions for common angles. So I'll assume that you already know how to find exact values for tangent 120 and tangent 45. Tangent of 120 would be negative square root of 3 minus 1 divided by 1 plus negative square root of 3 times 1. Again, negative square root of 3 is tangent of 120 degrees. Tangent of 45 degrees is 1. We need to continue simplifying our expression, and we want to make sure that our end result leaves no radicals in the denominator. So we'll start by rewriting this as negative square root of 3 minus 1 over 1 plus, or actually we can just say 1 minus square root of 3. Oh, excuse you, little baby. Alright, so in order to get the radical out of the denominator, because I have a binomial expression in the denominator, I can't just multiply by square root of 3. I can, however, multiply by the conjugate of 1 minus square root of 3, which happens to be 1 plus square root of 3. So I'll multiply both numerator and denominator of my expression by the conjugate of my denominator. Starting at the top and using the FOIL method, negative square root of 3 times 1 is negative square root of 3. Negative square root of 3 times square root of 3 will give us negative 3. Negative 1 times 1 gives us negative 1. And negative 1 times square root of 3 gives us negative square root of 3. Foiling the denominator, I have 1 times 1, 1 times square root of 3, which is square root of 3. negative square root of 3 times 1, which is negative square root of 3, and then negative square root of 3 times square root of 3, which gives me negative 3. I'll combine my like terms in the numerator. That gives me negative 4 minus 2 square root of 3 divided by, and then we have 1 minus 3, which is negative 2, and our two middle terms cancel out, which is what always happens if you multiply by the conjugate. Now, I can factor a 2 out of the entire expression, and at the same time factor out a negative. So in other words, I can factor out negative 2. That leaves me with 2 plus square root of 3, and that is my final answer. 2 plus square root of 3 is the exact value for the trigonometric function tangent of 75 degrees. That concludes our example. I hope you found it helpful. I hope the baby in the background wasn't too distracting. We'll see you next time.